welcome to our lesson this evening. Now, we are still expounding on what force can do for us, but we want now to look at something a bit different from what we were looking at in our previous lesson. Now, one of the effects of force is that it can influence. It can actually influence motion. It can influence motion. And when we say that it can influence motion, it can increase speed. It can actually trigger motion in case of a body at rest. It can decrease the rate of movement. It can decrease the rate of movement or even halt a body altogether. Based on this particular aspect of force, I want us to look at motion and get to understand better the effect that is brought about by force on motion. Therefore, let us look at motion. And motion is the change of position. The change of position of an object with time. Change of position of an object with time. Change of position of an object with time. Of course, it is brought about by some force, and therefore we expect that the change that is going to be realized of position is supposed to take place in the direction of action of the force. Now let us look at types of motion. Types of motion. And number one, we have what we call linear motion. We have what we call linear motion. And linear motion is the change of position of an object in a straight line. As the name suggests, the position of an object is changing in a straight line relative to the initial position of the same. How about circular motion? Is the second type of motion that we have, and this refers to motion that follows a circular path. Motion that follows a circular path. Say when you sit on a merry-go-round, or what we call the merry-go-round, the motion you are going to describe is what we call circular motion. And number 3, type number 3 is what we call oscillatory motion. And oscillatory motion is motion that repeats itself. Motion that repeats itself at regular intervals. Motion that repeats itself at regular intervals. For example, the motion that is going to be described by a carousel is motion that would follow a circular path like that, or what we call the circular kind of motion. However, if you consider a pendulum bob on a thread, if you swing it from A through B and to C, the path described by the pendulum bob will be A, B, C, B, A. Therefore, the bob will swing to C through B, and then the motion repeats itself at regular intervals, so that now it will then swing to A again and through B. That is what we call oscillatory motion. Now, let us look at terms associated with motion. Terms associated with motion. In this case, we want to narrow down to what we call linear motion. And find out what terms we have at our disposal when we want to discuss linear motion. And A is what we call displacement. And displacement is the length of path covered by a body in a straight line. Very important that it is and should be in a straight line. Displacement in itself is a vector. Again, we looked at vectors. It's a vector and is measured in meters. And symbolized by an S. So numerically, we can represent it as a velocity times time. If you take the velocity of an object, you multiply it by the time taken, you will get to find the displacement that is going to have been realized. Now, let us look at number 2, the second term. And the second term is what we call the speed. The speed and the speed is what we call the rate of change of distance. Rate of change of distance with time. It's the rate of change of distance with time. And in itself, it is a scalar. And the units of speed are meters per second. Numerically, you can say that speed is given by distance over time. Distance covered divided by the time taken. Now, there is yet another term, number 3, which we are now going to call the distance. And distance in itself refers to how much ground a body covers, and it is given the units again are meters. In itself, it is a scalar quantity. Therefore, the direction here is immaterial, and numerically, distance is given by speed multiplied by time. Let's look at the fourth one, which we are going to call velocity. Velocity is the rate of change, of displacement with time. Rate of change of displacement, and when the idea of the displacement is featured, it means automatically that our velocity becomes a vector because displacement is realized in a given direction, and therefore when you give a quantity the sense of direction, it qualifies to be a vector. It is measured in meters per second, and numerically velocity is given by displacement over time. Don't forget that V stands for velocity. S is our displacement, and T is time. T is time. Now, let us look at what we call acceleration. And acceleration is the rate of change of speed or even velocity with time. Rate of change of speed or velocity with time. Units are meters per second squared or meters per second squared, and the acceleration, which is written as small a, numerically is given by change in speed or velocity divided by the time taken. Seven is what we call deceleration. Other books will call it retardation. Other books will call it retardation, and it is the rate of decrease in speed or velocity with time. You can also define it as negative. As negative acceleration. It is also given by meters per second squared, and numerically it is given by change of velocity or even speed, and that we divide by the time taken for the change to be realized. Let us look at some examples involving those terms so that we can understand them better. Now, question number 1 is on a train that accelerates from 36 kilometers per hour to 54 kilometers per hour in 10 seconds. We are supposed to come up with the acceleration of that train, and we recall that acceleration is given by change in speed. You divide by the time taken, change of speed, you divide by the time taken, and here our speed changes from 36 kilometers per hour to 54 kilometers per hour. That is to mean that our change in speed will be given by 54. You subtract 36, these are kilometers per hour. So that now the change becomes 18 kilometers per hour, and the time taken has been given as 10 seconds. That change has been realized in 10 seconds. Therefore, change in speed divided by the time taken leads us to 18 kilometers per hour divided by 10 seconds. We first change speed to meters per second, which will be given by 18 times 1,000. 18 are kilometers. We want to change them to meters. We multiply by 1,000. And per hour, so we multiply by 60 to change the 1 hour into minutes, and again by 60 to change the minutes to seconds. And this gives us 18,000 meters divided by 3600 seconds. We can be able to cancel. And this gives us 5 meters per second. With the speed having been changed, to meters per second, we now go to acceleration, which will be given by 5 minutes per second. This one divided by 10 seconds, and it's going to give you 0.5 meters per second squared. We look at yet another question. Another question. Number 2. A truck traveling at 54 kilometers per hour slows down to 36 kilometers per hour in 5 seconds. Calculate the acceleration of the truck. That we have a truck whose initial speed is 54 kilometers per hour, and that one reduces to 36 in 5 seconds. We are interested in the acceleration, and acceleration is going to be given by change in speed. You divide by the time taken. Which again will be given by 36 kilometers per hour. You subtract 54 kilometers per hour, and this one we divide by 5 seconds, which is the time taken to realize the change. This gives us 18 kilometers per hour, which is very negative, and this one we divide by 5 seconds. 18 kilometers per hour. I want to change that to meters per second. So again, we change 18 to kilometers, 18 kilometers to meters, then our 1 hour by 60 to change to minutes, and by another 60 to change to seconds. And ngapi? 5 meters per second. But remember that it was negative. So when you're substituting, remember to carry the negative sign. Therefore, the change will be negative 5 meters per second. And we are dividing by the change in time, which again is 5 seconds. Therefore, giving you an acceleration of negative 1 meter per second squared. And now that this time our acceleration is negative, then we can term it as retardation. Retardation, or what we call deceleration. Let us look at another example. A maximum speed of a train. A maximum speed of a train is 90 kilometers per hour, it takes 10 hours to cover a distance, of 500 kilometers. Find the ratio. Find the ratio of its average speed to that of its maximum speed. To solve this, we recall that speed is given by distance over time, and in this case we have been told that it covered a distance of 500 kilometers in 10 hours. So with which speed did it cover that journey? We can cancel so that we are left with 50 kilometers per hour. That was the speed, the average speed of the train for that journey. But again, we've been told that its maximum speed is 90 kilometers per hour. Its maximum speed is 90 kilometers per hour, but the train covered the distance at 50 kilometers per hour. So what is the ratio? The ratio, remember we have been told, of the average speed for the journey to maximum speed. Let us substitute and simplify where possible. The average is 50 kilometers per hour and the maximum is 90 kilometers per hour. Now the units will go. Again, we can divide both sides by 10 so that we are left with a ratio of 5:9. That is 5:9. Again, when it comes to ratios, you've got to be very careful with the order. It is very important because if we were after the ratio of, say, maximum speed to average speed, It would be the complete reverse of the first one, where we would have 90 kilometers per hour to 50 kilometers per hour, which would have led us to 9 to 5, which is the reverse of the one that we had in the beginning. Our next example, example 4, walking a man covers a certain distance in 2 hours 45 minutes at the rate of 4 kilometers per hour. How much time will he need to cover the same distance? While running at 16.5. That a man covers a certain distance in 2 hours 45 minutes at the rate of 4 kilometers per hour, that is while walking. If he decides to run, the speed improves to 16.5 kilometers per hour. Now the question requires us to get the time he will take if he decides to run through the same distance. So number one, let's look at the solution to this. Number one, what is the distance covered? And again, this one will be given by speed times time, and the speed is 4 kilometers per hour, and the time is 2 hours 45 minutes. Therefore, we change the minutes to hours by dividing by 60, and this one becomes 4 kilometers per hour multiplied by 2.75 hours. Which gives us Remember its distance, so 11 kilometers. Therefore, if the man runs through the 11 kilometers at a speed of 16.5 kilometers per hour, what will be the time he will need to cover the same distance? Therefore, we want now to get time, and the time is given by distance over speed. Distance over speed, which in our case is 11 kilometers. 11 kilometers. This one we want to divide by 16.5 kilometers per hour. Which gives us 0.67 hours. 0.67 hours. Or if you may, you can decide to multiply by 60 to make it minutes. It's allowed. And that one will give you 40.2 minutes. That is what you will come up with. Now let us advance to something different, which also will require some knowledge on the same terms that we have been looking at, and this is what we call average speed. Average speed. Average speed. And average speed is the total distance covered divided by total time. Remember, we are talking about speed, therefore we have to pair it with a scalar, which in our case is distance. When you take everything, every distance that has been covered, sum them up, and you divide by the total time taken, what you come up with is what we call the average speed. Take an example. Martin drove his cousin at 20 kilometers per hour for 2 hours. He then drove from his cousin's to the store. Then drove from his cousin to the store a distance of 30 kilometers at 10 kilometers per hour. What was his average speed? What was his average speed? We are after the average speed, which means we have to consider total distance and total time. Now, Martin drove to his cousins at 20 kilometers per hour for 2 hours. So for that bit of the journey, the distance is going to be given by speed times time. And in our case, we have 20 kilometers per hour. You multiply by 2 hours, which gives us 40 kilometers. And time for that bit of the journey is 2 hours. Then there is the next bit. There is the next bit where he drove, that is distance 1, distance 2, he drove for 30 kilometers and at 10 kilometers per hour. So we want to find out what time did he take from his cousins to the store. Now, speed was 10 kilometers per hour. Therefore, time is going to be given by distance over speed. This distance divided by speed, which is going to be 30 kilometers divided by 10 kilometers per hour, which will give us 3 hours. Now, total distance will be the first distance added to the second one, which will be 30 kilometers plus 40 giving us a total of 70 kilometers. How about the total time? The first bit of the journey took The first bit of the journey took 2 hours, while the second one took 3 hours, which gives us 5 hours in total. Now, so the whole journey took 5 hours. The distance covered, this is the total, was 70 kilometers, and the total time taken was 5 hours. Therefore, with this information, we can go ahead and get the average speed. Average speed for the whole of that journey is going to be total distance and you divide by total time, which will give us 70 kilometers divided by 5 hours, and this one gives us 14 kilometers per hour. So basically, we have been able to look at the terms that we associate with linear motion, and we have been able to calculate each one of the quantities as well as classify them as either vector or scalar quantities. Now, next time we meet, we are going to look at the motion graphs. Motion graphs. Motion graphs. And motion graphs basically are graphs that shows how two quantities for a given body in motion compares. For example, you could look at what we call distance time graph, where you have the time and you have the distance. Then you would like to find out how will distance respond to a few factors that you are considering about a body in motion as time goes by. We shall try and draw different kinds of them and even go ahead and interpret them in our next lesson. Thank you.